One of the important things we'll need to learn how to do from a factored polynomial is finding the power function and the constant term. When you have a standard form polynomial, it's actually very easy to find those two things. And I'll just give you an example here. Let's say you had some polynomial g of x. And, I'm just going to make this up. Let's say it was negative 5x cubed plus x minus 7. Well, there's the constant and there's the power function, right? They're just looking right at you. So that's very easy. But when it's in factored form, it's difficult because they're not so obvious, right? What would the leading term of this be? Well, maybe we should expand this thing out. Maybe we should do all those multiplications and get some huge polynomial. It would take me like half an hour to expand this thing out because there's so much going on here. So when you have a complicated factored polynomial, we still want to be able to find these power functions and constant terms, but we need a quick shortcut, and that's what this video is going to go over. So here's how you do it. Let's talk about the constant term first. If you think about what a polynomial is, and where that term at the end comes from. Here, let's use an example. Let's say g of x equals x minus 1 times x plus 3. Okay, this one is easy to expand out. I would say that is x squared. I'm going to do a little stuff in my head here, and if you want to play catch up, you can pause the video and do it on your own. But this turns into x squared plus 2x minus 3. Now the question is, what's the shortcut I can use to find this minus 3 from the factored form? Well, if you take a look at these numbers right here, this 1 and this 3, if you multiply all the terms on the right together in each of those parentheses, in the end, you'll get whatever term is all the way on the right in the polynomial. So hopefully that makes sense from a spatial point of view. Let me give you another reason why this is working. When I multiply things together from factored form, you're multiplying every number times every number or variable. And if you want to get something with no x's on it, the way that happens is by multiplying together everything else that has no x's on it, okay? Which is usually all the stuff on the right side of the equation. So let's do an example with this one. And let me just change my color here so we can see all the new ink. If I want to know what the constant term is, here's how I go about it. I say negative, because the negative is still up front. We have to deal with that. Negative 1 squared times negative 3 times negative 2 squared times negative 1. Okay, now that's not so bad. We just have to work through all these terms here. So we have negative 1 squared is just 1 times negative 3. Negative 2 squared is 4 times negative 1. So I count 3 negative signs. That means this is going to be a negative. 1 times 3 is 3, times 4 is 12. So we have negative 12. That's our constant term. And that really was pretty quick. You just multiply all the numbers together in the factored form. Now, another way to talk about the constant term is to think about this as a graph. And we'll get into the graphs of these things later. But just pretend we're going to graph f of x. And I don't know what its shape is. I'm just going to draw some wiggly thing here. And of course, I drew something that can't work. So let's pretend it's that shape. So how would we find the y-intercept of a function? Remember, the y-intercept is the constant term from standard polynomial form. The y-intercept is found by saying, hey, wait a minute, this right here, that's the y-axis. What's x equal to on the y-axis? X equals 0, because it's the y-axis. It's right in the middle. Over here you have very large x. Over here you might have a very small or very negative x. The y-axis is what runs right in the middle. It's at x equals 0. So what you do is you take x equals 0 and you plug it into that original equation. Well, look what happens when you do that. All these x's turn into zeros, right? And all you're left with is the numbers. It's the same idea that we've been going over. Okay, so hopefully that clears it up a little bit. This is how you find the constant term. You just multiply all the numbers together on the right. Let's go over the power function now. Or not the power function. Let's go over the leading coefficient. I think we want to take this in steps. Leading, you know what? No, we're going straight for the power function. For the power function, remember what this is. This is the term of the polynomial which has the highest exponent. Okay, right? The highest number over x, which means anywhere you see an x in this factored form, you have to multiply it together. Because only if you multiply all the x's together can you find the highest power of x. So instead of multiplying all the right terms to get the constant, now we're going to multiply all the left terms to get the power function. So we have negative times x squared times x times negative 3x with the squared on the outside of it times another x. And if you look back at the original form of this function, see those x's that I circled in there? You can see where these parts are coming from. So let's just work through this. We have negative x squared times x times, this one's 9x squared times another x, which gives me negative 9 times, well, let's count up our exponents, 2, 3, 4, 5, 6. I think that's negative 9x to the 6th. That's my power function. So it has a leading term of negative 9, a polynomial degree of 6, and we'll find these things very useful later on.